The fifth launch of Starship was a historic event and the greatest success achieved so far by SpaceX in its ambitious project to build the most powerful rocket ever created. On October 13, 2024, for the first time in the history of astronautics, a rocket was able to return to its launch pad and be caught mid-air by a system of robotic arms installed on the launch tower. This is an absolute milestone, representing not only a technological triumph, but also a turning point in the space industry. The images of this extraordinary event, which circulated worldwide, will remain etched in the history of space exploration. The rocket at the heart of this achievement is the Super Heavy Booster 12, the first stage of Starship, equipped with 33 Raptor engines. These engines, unlike traditional ones, use methane and liquid oxygen as propellant, offering unprecedented efficiency for rockets of this size. On October 13th, just 5 minutes before the launch window closed, Booster 12 ignited all its engines, propelling the massive spacecraft towards the stratosphere. The thrust generated by the 33 engines allowed the rocket to lift off with incredible power, demonstrating the potential of this new generation of space vehicles. Unlike previous launches, which encountered difficulties during the stage separation of the rocket, this time Ship 30 separated smoothly from Booster 12 thanks to a complex maneuver called hot staging. This technique involves igniting the second stage engines while still attached to the first stage, improving the efficiency of the separation and reducing the overall time of the maneuver. About 2 minutes and 35 seconds after liftoff, 30 of the 33 Super Heavy engines shut down, allowing the rocket to begin the separation phase, leaving the 6 engines of Ship 30 to ignite. One of the most complex and crucial phases of this flight was the return maneuver to the launch pad. After separation, Booster 12 activated its grid fins, stabilizing grids that allow it to orient itself during descent. Thanks to this technology, the rocket was able to perform the necessary rotation to return to the launch pad. In an incredible engineering demonstration, the exhaust gases from Ship 30's engines were used to help the booster maneuver precisely, pushing against the control grids. Once fully separated, Booster 12 reignited 10 of its central engines to begin the boost-back burn maneuver, necessary to reverse its flight path and bring the rocket back towards the pad. This maneuver required perfect coordination between the onboard systems and the flight controllers. The rocket continued its descent, using Earth's atmosphere to slow down and directing itself toward the launch tower. The final phase of re-entry marked the climax of this historic launch. After about 6 minutes and 30 seconds of flight, the booster reignited 13 engines to further reduce speed, and in just a few seconds, it decelerated from over 1,200 km to just 250 km. At that point, the rocket shut down all engines except 3, using them for the final approach. The descent was not perfectly vertical, but this was intentional. SpaceX preferred to maintain a slightly inclined trajectory to avoid the risk of a direct collision with the pad in case something went wrong during landing. The images of the booster slowly descending towards the launch tower, with aerodynamic flaps at the base keeping it properly oriented, were impressive. During the descent, the protective shield around the engines became incandescent due to friction with the atmosphere, a predicted phenomenon that clearly showed the thermal challenges SpaceX had to face. Despite the breakage of one of the aerodynamic flaps at the base of the booster, the rocket managed to position itself precisely between the arms of Mechazilla, the robotic structure used to catch the rocket mid-air. The arms promptly closed, capturing Booster 12 and successfully completing the recovery mission. A few hours later, the rocket was relocated to the pad for further analysis and checks. SpaceX also carried out the refueling of the booster's tanks with cryogenic fluids to safely empty the remaining propellant. The success of this flight is not just about Booster 12, but also Ship 30. After reaching an altitude of 150 kilometers and a speed of about 26,500 kilometers, Ship 30 continued its trajectory into space, before beginning a long re-entry maneuver into Earth's atmosphere. Unlike previous flights, SpaceX installed more cameras on Ship 30 to monitor the behavior of the wings during descent, providing valuable data for future developments. The re-entry was marked by the formation of plasma on the heat shield, a delicate phase where compressed air generates extremely high temperatures. Thanks to improvements in the design of the heat shield, the prototype did not suffer significant damage and continued its descent to a precise splashdown in the Indian Ocean. This flight marked a significant step forward for SpaceX, which plans to conduct up to 20 test launches in the coming year. The evolution of the Starship project will continue gradually, with the transition from version V1 to V2, which will bring further improvements to the rocket's structure and performance. In conclusion, we remind you that SpaceX has already obtained permission to conduct the sixth flight, which could take place in the coming weeks. Thank you for watching this video. Don't forget to subscribe to the channel to stay updated on future Starship launches. See you soon.